My name is Alexis Conachen, and we're going to be talking about the thermal expansion and rotating equipment, specifically in steam turbines and compressors. So we're going to learn what thermal expansion is and how it affects those two types of machines. So, what is thermal expansion? So basically, turbines and compressors get extremely hot. So when your metal heats up, the metal's going to increase in size. And it happens through this very simple equation we all learned in probably strengths. And it can cause several millimeters of shaft growth and the case to grow. And this is critical before alignment, clearances, and reliability issues that this would cause. So, to start out, a steam turbine. The inlet of steam going into the turbine is the hottest point in the turbine process itself. So, you're going to expect the most growth of the turbine when the steam enters. Now, you're going to have a thrust bearing, which acts as the stationary on your rotor in a steam turbine. So you're going to expect your rotor to grow away from your thrust bearing. And in doing this, you can tell from this drawing, you have very tight clearances from where your wheels are going. So if you're expecting your turbine to move at all, you need to account for how much it's going to grow. So for example, if I have a turbine that's running at 3,600 RPM with an inlet temperature of almost 1,000 degrees Fahrenheit, my rotor is going to get up to almost 1,000 degrees. And so you can expect it to grow about 5 to 15 millimeters, so up to 0.6 of an inch, which could be catastrophic if you didn't account for that in the clearance. Where this blade's going to go, if it hits or touches, that's catastrophic failure for your machinery. So, that's for a turbine, but in compressors, we can expect that our most thermal expansion is going to be on the discharge side, as opposed to the inlet. So we know that in compression, our temperature is going to be hottest when there's an increase in pressure. Right? And so at your discharge, you're going to have the most pressure, therefore you're going to have the highest temperature. So you can expect the most thermal expansion in the compression and discharge stage. However, almost all compressors have intercooling systems because thermal expansion is such a big deal. After each stage in a compressor, your pressurized gas is going to go through an intercooling system to bring your temperature back down, so that thermal expansion does not have much of a role to play in your machinery. So, this is a Baker Hughes horizontally split compressor, and it runs up to 20,000 RPM. Now, you can tell the inlet pressure is 15 bar and your discharge 60 bar, so that's a very large pressure differential. And you're going to have several intercooling stages in this compressor. So, your inlet gas, about 40 degrees Celsius. It's going to go through a stage of compression, and it's going to have an exhaust of 120 degrees Celsius. That's a large difference. So then you're going to go through an intercooling process before you go back to almost your inlet temperature after your intercooling stage. And then it's going to go through another compression stage, and then another compression stage. So your rotor axial expansion will be 1 to 4 millimeters. So your intercooling temperatures, your intercooling stages, keeps your thermal expansion smaller than the thermal expansion of your turbine. Your compressors aren't going to grow as much as your turbines are. Alright, so we have a turbine and we have a compressor, and they have to be coupled to each other, and they're going to grow differently from one another. So you have to account for the fact that they're both going to grow separately. So when you couple them together, you have to offset couple them, right? So if I have, and this will be in your engineering drawings that you'll be given, but if I have a turbine that's going to grow here and a compressor that grows here, once I couple them, I'm going to stretch the coupling, and when they're running, they're going to even out towards the middle and run together. Alignment is extremely critical. If your rotor is offset at all, it could cause catastrophic failure to your machinery. So pre-stretch alignment is extremely critical because it prevents vibration issues, it prevents seal damage issues, and bearing failures. So It's essential for reliable operation. You go ahead. Now, how do we know which way the compressor or the turbine is going to grow? How do we know which way it's going to expand? So there are going to be some visual indicators, especially there are going to be anchors. So anchors on the outside, they're key anchors. So these keys show you which way your casing is going to move, which way it's going to grow. And then you're also going to have differences in bolt sizes. So if I have a larger bolt on one end of a compressor compared to the others, the larger bolt tells me that it's holding together the more pressurized side, which means there's higher temperature on that side. And in the end, you're going to have engineering drawings that confirm the exact expansion direction. So to conclude, thermal expansion occurs in turbines and compressors due to high operating temperatures. Turbines experience greatest expansion at the inlet, while compressors are towards the discharge. Clearances and interference fits are critical to prevent contact. Pre-stretch alignment is extremely important, and visual indicators such as keys and bolt locations identify expansion directions. Questions? Okay.
Awesome. That's all.